My name is Sarah. I'm from Giatec. And before I start, I just want to mention that I am not the brain behind any of this machine learning. So this is non-technical whatsoever, and it's more around like how we've been using AI and then providing those AI tools to some of our customers. So real application or real life example of what's being done today. This presentation is really simple. I'm going to go through three examples. The simplest one we've done, so how we tiptoed into AI, and what we're doing right now. So kind of the evolution of what we've been implementing. So first of all, just super brief introduction. Like they've mentioned earlier, we're not here to tell you like, hey, we're using AI, this is what you should be doing. What we're using AI for is really to provide validation, alerts, suggestions. So basically what we're trying to build for our AI tools are like tools for you to make decisions, right? We don't want to replace you, we just want to give you everything we know and just give you an extra data for you to make a decision on how you should move forward. So let's start with the simple example we have, and it's concrete pouring time detection. So this seems a bit weird, but basically for people that don't know Giatec, we make sensors. So we put sensors in the concrete, and what we do is we measure temperature, and then with that temperature, we use the maturity method to output strength. So we're sitting here, and we have a lot of data. We have sensors that have been used in the field for over 8 years. And those sensors are in different types of concrete, different weather conditions, different types of application or installation depth, and it's worldwide, right? We have those sensors in 85 countries and over. So what we're looking at is, this is just samples of like, just regular temperature data that we have. And then as a concrete expert, I can easily detect where my concrete pouring is. So basically what concrete pouring for us is, when did the concrete touch the sensor? Because all of the data before that is useless, right? In terms of temperature measurement, in terms of this is the maximum temperature achieved or minimum or strength measurement. So basically what we want to do is basically say, hey, ignore everything that's before pouring. I don't really care from a concrete application. So as an engineer, I can easily detect where that temperature pouring time is. And if you look at those, like the first one is pretty simple, right? You see ambient, and then poof, it jumps up, and this is a mass concrete element. So can we build something in machine learning that can go through this and actually detect this for you? Because first we were asking customers to put that value in for us to be able to do calculation, but what can we do that for them? So this has been done over 4 years ago. So this has been implemented in our product for a long time. And basically the only thing we do is we look at this temperature profile, we use the machine learning algorithm we have, and then we basically provide a suggestion. So customers would input a value, I don't know, a couple hours, like 5 hours earlier. We look at this, we're like, it looks like there might be something wrong. We're suggesting something new for them. And then we allow them to accept, reject, and we keep learning, right? So we know who's rejected the value and who's accepted it, and then we can use that data to make our algorithm better. So this is like the simplest application of AI that we've been using. So let's move on to one that's a bit more complex, and is, can we validate your maturity calibration? And can we understand the mixed performance? So once again, we're sitting on a really big amount of data set in terms of maturity calibration. We have like thousands and over of maturity calibration curves, which look at the bottom left on the screen. So they're basically a maturity versus strength. And this is a calibration that's required for ASTM C1074 that's required to use this method and output strength. The calibration's a bit lengthy process, and people are kind of new at it usually, and they're like, is this right? Like, am I doing this right? Is it the right data? I'm not too sure. So basically what we've done is we partner up with 12 producers at the moment. So this has been out there for 3 years in the public. So we've partnered up at that time with around 12 producers, and we collected all their mixed data and the mixed performance. So basically, if you look at the image on top here, what we've done is we collected, like, we're looking at the cement type, quantities, mix design basically, and we put this in the machine learning, the dump, like the brain stuff that I cannot speak to, and then we output the strength, the air, the slump. So we're predicting what it's going to be the output. So we're using it this way in order to do two things. The first thing that we're doing, and by the way, Roxy is just our AI tool, a fun, nice name for this. So basically what we're doing, we're saying we're using the input that the customer provides on their calibration and their mixed designs. And we're taking this, we're blending this up, and we're saying, hey, it looks like your calibration is a bit off. Like you have, and taking this example is, it's too low of strength, or not too sure. So basically what we're doing is we're taking the mixed design, we're making our own strength maturity curve, and we're plotting it with what they provided, and is it within that 10% accuracy that ASTM allows for, and then we just warn them if there's something that we think is wrong. And this is really, a lot of our customers love it because they can just validate. If it's the first time using it, they're not too sure, and it gives them that peace of mind that, hey, I think I've done this right. And if there is something wrong, they usually call us and like, hey, it's not working, what's going on? And then we can pinpoint like, hey, you did try this because this is, you're gonna have issues. So, right, we can be really helping them and making sure that this doesn't get deployed in the field and oops, something happens, right? So we pushed it a little further than this, and we also ask for mixed specification, specified performance, sorry. So one of the things that we can do with this is basically what we're doing is the mixed design you provided, we're lowering a bit the cement content or the water, like the cement content, for example, and we're providing suggestions like, hey, we think that you can actually save on this mix. Like, it's working, your maturity is good, but next time, you know, talk to your producers. It looks like you can reduce your, you can reduce either cost or CO2 by removing some of the cement that you have in your concrete. So we're providing suggestions by keeping the same water-cement ratio or just keeping the same water content. So we're just providing those high insight kind of suggestion. Once again, suggestions, but also could be really useful for you to save time, money, CO2 in the future. Where things get a bit more fun is when we keep going on this. So those two applications are live, they've been out there for a really long time, but we didn't stop there. So what we kept doing is, can we actually do concrete mix optimization? So the first thing that we're trying to solve is basically around the CO2 consumption. So a lot of the mixes that were out there are over-designed. So this is the NRMCA is in blue, I believe, and this is our AI. So there is a really strength over CO2 footprint for the mixes. So for the same strength, let's say, for example, you want to achieve, this is in metric, 40 MPa, you can achieve this 40 MPa different ways, different mix designs, but it looks like there's a clear way we can improve on the CO2 consumption and reduce the amount of cement you're going to use. So the first idea was like, hey, can we do mix design that are a bit more environmentally friendly? So there is a lot of potential around this. So how we're doing this? So we're going from 12 producers to the biggest data set that we have is over 200,000 concrete mix, over 1,500 plants. We have 50 million concrete deliveries data tickets. We have 10,000 raw materials and how they behave in their chemistry and so on, and data sets that are in over 20 countries. So we have a lot of data. Like, let's put it this way. And you can see here, this is just an example of some of the data in different countries and how the total cementitious versus the strength is distributed. And once again, you can see that if you want to achieve a certain strength, this one's in imperial. So if you want to achieve 6,000, for example, there's a wide range of mix designs you can have to achieve this. This is only one. Obviously, I'm just looking at strength, but we're looking at a lot of other things, and it gets more complicated and complicated. So what are we actually wanted to do with this? So let's go back to that amazing drawing that I had earlier, where the first thing we did is give us your mix design, we're going to give you your specified performance, but what we're doing now is we're reversing this. is give us your mix specification in terms of strength, your air, your slump, and so on, and we're trying to make a mix design for you. So we're flipping the coin here, but it's not that easy to do. Sorry, I don't know why there's animation on this. Okay. So concrete is ordered to meet a specific performance, and there's different things that are really challenging. So we're trying to monitor. There's not a lot of like raw data monitoring tools out there because the cement changes every day in your plant. In what you're receiving, the aggregates can change. Everything can change. There's not a lot of visibility on the real-time performance of concrete on site, right? And then getting all of the data together is also something that's missing in the industry. So basically what we're seeing with all the data, and one of the other challenges we're trying to do is that everything has been roughly overdosed by 20%. So the challenge is that we're designing for that specified strength, which is that dotted line here, but we are super conservative, right? And we're trying to, what we're actually designing for is the blue line. So there's a lot of room to improve. And this is not simple to do. So in order to actually understand what's going on, we're getting data from everywhere, right? We're getting data from the lab. We're getting data from the raw materials, or the new systems on the trucks, the third-party labs, field data. We're just getting all of that mismatch in an algorithmic system, and then we keep learning. We keep adjusting, and we keep learning on a way to improve. So that being said, sorry, it's a bit, there's a lot of stuff going on in the background, which, like I said, not too familiar with. But basically what we want to do is put an AI tool for the public to be able to leverage all the knowledge we have. So basically what we're doing is we're identifying opportunities and providing recommendations. So as a producer, you can put in your mix design, and we're looking at the performance over time and so on. And what we're doing, I don't know if you can see it well, but here at the bottom, we can provide optimization. And customers can decide, okay, I'm going to optimize on cost, I'm going to optimize on CO2, or both. And we're providing, we're saying, oh, we think you can save some money on your mix or some cost on the CO2 side of things. And then what we're doing is that we're providing them different scenarios. We're not saying, hey, we think this mix is the perfect mix for you. We're actually providing them a list of mixes, mix design with little variation between them, saying like, we think those mixes could actually do the trick for you. And with different, in this case, there's 3 different scenarios. And I encourage them to actually go and test those mixes out. We're not saying, take this, what we told you, dump it in your mixer, and you're going to have the right answer, right? We're just providing tools and guidelines to be, hey, we think you can optimize. We're suggesting this. Go and have a try at it. So this is, Tony, is it live? Is this live right now? Can people use it? Yes. Okay. So I'm talking like a month or 2 fresh. Okay. So this is currently in use. We do have producers using it, but we're still learning. We still have a lot to learn. There's still a lot of challenges, which if you are concerned with some of those challenges, you can come see me after. Maybe I can talk to you about them. But this is not a simple task, and we're providing something that is new, and we're hoping to solve some of the issues that we're currently seeing in the industry. So this is all I have for you for today. Does anyone have any questions?
Sarah, excellent talk. Yes, Pierre.
Hi, Sarah. Thank you for your presentation. Very instructive. I was just wondering, do you have any feedback loop for your Roxy tool if the producer actually do changes, or based on your suggestions, or?
Okay, this is where my my role ends. So that would be a question for gentleman sitting here in green. Maybe you can answer. I'm really sorry about this. Go ahead, Tony. This is Tony. This is his product. Sorry, I'm just a bypass person to present on this.
Sorry, could you ask the question again?
Do you have any like feedback from the customer if they actually use your suggestions, and what is the impact in real of those suggestions?
Yeah, so we're just getting started with our early access, so customers are just getting into it.
It was for the Roxy one, the second case scenario you presented.
Okay,
Sorry.
So for the producer side, typically what happens is that we provide those suggestions. And it's basically the reduction in cement is more like a visibility. Mostly general contractors are going to see this and they can talk to their producers. But it's not an easy thing to do because then you need to change the calibration and there's like a different dynamic. We have some people that have used it and actually save because the suggestion we provided them. Some people just disregard it because that's the mix. They're just not going to change their mix. But we did have some cases where people were like, hey, we're doing this. But the entire goal is not to make them optimize on this page. It's just to kind of show them, hey, there's something that can be done on both sides.
Thank you.
Thank you.
Other questions? Yes.
Good morning.
Good morning.
Impressive presentation. Thank you. My name is Hassam Azar Jafari, and I'm working at MIT Concrete Sustainability Hub. I have a relatively basic questions. Could you comment if you observe any correlation between strength and GWP?
And sorry, what?
A correlation between the strength and GHG emissions of the mix.
Yes. I don't know if we can go back. Oops. So basically, here. So.
I see how stupid.
No worries. Actually, like this is an input that customers need to provide. So we're looking at transportation cost. So there's each material has a CO2 component to it. So when we try to optimize, depending on if you're asking for CO2 optimization, the model is gonna push towards material that are less CO2 demanding. So for example, if you query your aggregates right there versus shipping them, we're probably your mix is probably gonna be a bit more weighted on the aggregates because they're coming from right there versus shipping them, right? So each material does have a CO2 impact on them, and depending on what you want to optimize for, it does. Tool is so smart. It does provide you mix design in accordance to what's either cheaper, more expensive, or CO2 versus less CO2. One more?
Yeah.
Good morning. Just a quick question. You do a correlation between temperature and strength, right?
Yes.
Now, this strength is the theoretical strength, or that is the result of the cylinder test?
So this is the results of the cylinder test, and this is a big loaded question. So we're currently in the process of releasing a sensor that's going to go in the concrete and measure strength without any requirement of calibration. So the idea is that we start getting real life strength data on the field, and then we can correlate that back. Right now, all the strength data we're getting from the field is based on a maturity calibration. So basically strength, understanding what's your temperature profile with that strength and correlating that. So that's what we have right now, but we're pushing the boundary even further to try and actually what's real life strength and bringing that back in a big loop. Yeah. Thank you.